Hey guys, this is Will with SRT Amplification, and today on the bench we have a Lazy Susan. No, this is not what I want to show you today, but I did get this in the mail. Lazy Susan. I'm going to be putting various pieces of test equipment and amplifiers and stuff that I work on this thing, and that way when I make videos I can just turn this thing around and not have to manhandle it. But we'll see how it works for large items, but today we got a small item I'm going to stick on the bench, and it is this puppy right here. Get you guys zoomed in here. Alright, so this baby is a Nixie tube voltmeter. Well, it's a multimeter actually. It does volts and resistance. So take it for a spin here. All right. So interesting thing. I've always wanted a piece of equipment that had Nixie tubes. Okay, and they still make Nixie tubes. Somebody's making them somewhere. For these Nixie tube clocks and stuff like that. But I wanted a true piece of test equipment that used Nixie tubes as a display. And I found this online, and yeah, it's only a 3-digit meter, but I just thought it was cool, and I'm gonna actually use it. So we're gonna power this thing up. It looks like, oh, let me get in here and show you the brand. It is a Systron Donner multimeter. The features that it has, not very many. It's got an on-off switch. It's got, this is some kind of triggering device or something to have it hold, I guess. I'll have to read a little bit on that in the manual and see exactly how that works. I guess you can have it hold on a particular value or whatever. Maybe a max and a min or something, I don't know. And then you got your volts and your common. So for your voltage, banana clips or banana jacks, and your common and your resistance reading, ohms over here. And then you've got various ranges here. 1.5 volts, 15 volts, 150 volts, 1 kV. And then on the ohm side, you got up to 5K, 15K, 150K, 1.5 meg, and 15 meg. That's how that works. So like I said, this is only a 3-digit multimeter. So the resolution is not there. So, I mean, if you really need to get down to the millivolts or, microvolts or anything like that, this is not going to do it for you. So, like I said, the lowest range is 1.5 volts. So that would mean that the lowest you could read on here, I believe, we'll see when we power it up, but I believe the lowest you could read on here is down to 10 millivolts, I believe, is as far as it goes. We'll see where the decimal is on here. But it looks like somebody has put a vacuum cleaner cord on this thing. This is not original, doesn't look like, to me, anyway. So I'm going to bring this thing up on the Variac, or on the dim bulb tester anyway, and we'll see if it powers up, and then we'll break into this thing and look at it and see what all's in it. Let's see here. Plug this into the dim bulb tester. All right, it's not drawing excessive amount of current. We'll turn it on, see what happens. Hey, looky there. We got something. All right. I don't know how well that's showing up on the screen because it's kind of, when I move it right there, it looks really crisp in real life. It's totally washing out on the video. I know, I'm sorry for that, but in real life, it's really crisp red, almost orange, but really more red. numbers. Wow, I wish that showed up better on the, maybe if I zoomed in a little bit. Nope. Well, you can kind of see that it's just, wow. I really wish you guys could see it the way I see it. It looks so nice. Well, that doesn't look bad. That's not bad. You can see it's kind of digitized, but it looks really good in person, like really, really good. So I had to do some research on this. Let me zoom back out here. I didn't, I haven't researched this particular thing, but what I wanted to know is I'm sure this is all solid state. The metering and everything in here is solid state, and so I was curious to know why they didn't have solid state types of displays at this time. And I found out that in the 50s, the first digital displays came out in the 50s sometime, like 1954, and they were what was called edge lit displays, and they were basically just stacks of glass or plastic, clear plastic, 10 of them with numbers etched on them, and there would be a light bulb on the edge of it, and whichever light bulb lit which glass, that number that was etched in there would display, right? It's kind of like these are, all these digits are kind of stacked behind each other, and you only see the one that's lit. So it's almost similar to this, but it uses separate bulbs for each stacked. And then HP had a digital display, kind of, sort of, in which they would have a row of numbers 0 through 9, various columns, and they would have a light bulb. Each number would be clear plastic, transparent, and they'd have a bulb behind each one of them. And if you wanted to read like 1.99 volts, then the 1 would light up, and the 9 down here would line up, and the 9 over here would line up. Anyway, I'll show you a picture of those. So you can see what I'm talking about. But anyway, the thing that that came after those two and was probably the most popular before LED displays started being implemented was the Nixie tube. And then once LEDs came in and they took over, and basically everything was LED, 7-segment displays or multi-segment displays or whatever. And then the LCD came along later, and it pretty much took over everything. And now we've got touch screens and all kinds of stuff. Anyway, I want to feed a voltage into this thing and see if it actually works. I know it's jumping around here, and I don't even see the decimal point, so I don't know where the decimal point is exactly. This thing right now is saying it's reading 478 volts. But let's see what we got. Let me grab some things here. Okay, so we got that, and we'll just okay, so I don't know if you can see on the meter, but it's reading 0006. It was down to 000 earlier. I've got 000 on my DC power supply here, and as I crank this up, it's going up. That's 0.5. This is reading 0.6. I'm up at 1 volt now, and this is reading. See, the decimal's not moving. So this went up to one. This went up to 2 volts now, or I don't know what this is doing. The decimal's not moving. I've got this up to 2.7 volts, 3 volts, nothing. Let's look at the 15 volt range. That should move the decimal over. This is showing 5.1 volts. I've got 3.2 volts. Huh. So there's probably some calibration that needs done on this thing for sure. When I put it on the 150, it moved the decimal over here. And then when I put the 1000 on there, obviously with a 3-digit meter, you can only read up to 999, right? So 1,000 digits, 1,000 counts, right, is a 3-digit meter, 1,000 counts. So not 0 to 999. But yeah. Oh, that brings me to something though. We'll run through the calibration on this thing once I find the service manual and everything. But I just wanted to bring this up. This thing's obviously not calibrated. There's probably some things wrong with it. But one of the things that I've been looking at online and stuff, and a bunch of forums and everything, and I see it all the time. People talk about meters and how many digits and counts and stuff it has, and you got these 7.5 digit meters and 8.5 digit meters and all this stuff. And I see a lot of people get this wrong all the time. They link the amount of digits or the amount of counts that a meter has with the accuracy of the meter. And I can understand why they do that to a certain extent. But when they say that this meter is more accurate because it's got more counts or more digits, is totally not correct. It may be more accurate, but it's not because it's got more counts or more digits. It's just because it's more accurate. But I can kind of see their point if they're really thinking about it. And I don't know if they're really thinking about it, or if they've just been told that, hey, the higher digits or higher counts, the higher resolution a meter is, the more accurate it is. It's two different things. As a matter of fact, most meters have a certain resolution, right? And that resolution doesn't change, but it'll have different accuracy percent accuracy numbers for the over the range of the meter. So it's not accurate to 1% full scale or whatever over the entire range. So once you change ranges, the accuracy may change. But anyway, now I will say this: normally, if you buy a meter that has more counts, in other words, has a higher resolution, more digits, right? They tend to be more accurate because you're paying for that, and those types of high-end meters tend to be more accurate. Now, if you want to look at it from the aspect of well, they're more accurate because I can read all the way out to 1 microvolt or whatever. So I know exactly what it is. Well, yeah, no, but it's really the resolution, because I could put 3 volts, a real 3 volts in here. And if it said 3.00, yeah, I don't know what's way out here, right? But it could actually be telling me, this meter could be telling me that I have got a 3 volt, and it could be 100% accurate. I don't know of any meter that's 100% accurate. But what I'm getting at is you could have meters that, they say that they're accurate and they're off their accuracy. No, I don't care how many digits they have. If they're not calibrated and they're not within the specs that they were produced to be in, they could be totally inaccurate. So The accuracy has nothing to do with the resolution. The resolution stays the same within the meter. If the meter has a certain amount of resolution, it always has that resolution. But its accuracy can change. Resolution's more of a precision type of thing. Like how precise can you measure it? Can you measure it down to the microvolt? Accuracy is how close it is to the true value. So, if you were to relate that to, let's say, firing arrows into a target or firing a gun into a target, target shooting or whatever. If you got all of your shots in a quarter size area, or in a something this size right here, you got 10 shots in this size right here, you're very precise, right? But if they're way over here in the target and you were aiming center mass, your precision was good, but your accuracy was not so good, right? But accuracy is a form of calibration, and so you can get that back into spec by just adjusting your sights. And as long as you maintain the precision that you had with your shot group, then you can be both accurate and precise. That's how I kind of look at it. And yeah, I do know that they're related because, like I said, the more precise the meter, the more resolution it has, the more accuracy they tend to have. But that accuracy is not always the same over all the range of that particular meter. Anyway, that's my rant for the day. Let me unplug this and we will open this thing up and look at it and see what's going on in this bad boy. Oh, we're gonna need, oh, I love this Lazy Susan already. I am loving this Lazy Susan. I mean, I just used it now for the first time in this video, and I'm already loving it because it just makes things so much easier. So I have a Phillips head screw right here in the back. That's going to be an easy one. Maybe this is going to be it. There's probably some underneath. We'll see. Open this bad boy up. Doesn't look like there's anything under here. And you think this thing just slides out, right? It does. That one screw. There's a little piece of rubber that fell out. Another piece of rubber that fell out. This thing's just going to slide right out of here. All right. So, yes, it looks like somebody has tacked in this vacuum cleaner cord right here. And this fuse, this all got tacked in ex post facto. So that's very interesting. Let's look at the top side and see what the way it would have been, possibly. I don't know. Maybe that's the way the original was tacked in there as well. It looks like it could have very well been. All right, so let's look at the top here. You can see the Nixie tubes. Now, they did make Nixie tubes that were also top viewing. And so these would not have been closed off in the manner that they are here. They would have been a smooth top tube, and the display would have faced out like this. And so then, you would have had a diffuser or whatever right here, and you would have read the numbers that way. They did have Nixie tubes like that. So you have this stack switch right here. 3 tubes. I believe the plus minus is just a neon bulb. I believe, or a couple of neon bulbs in there. Yeah, there's 3 neon bulbs in there for that light up the different things over here on the other side. Plus, minus, and possibly something else, I'm not sure. But this is a fairly simple device. It does have a few ICs. 1, 2, 3, 4, 5, 6 ICs. I don't know what they are. I can't read them. They're not TTL logic or anything like that. Doesn't look like. I'll have to find out what those ICs are exactly. Transistors, capacitors, power transformer, linear power supply. Here's your diodes here. It looks like a full a bridge rectifier, 4 diodes there for your power supply. Power supply main filter cap looks like, or this one's your main filter cap maybe. Is that 100? Well, that's only a 10-volt cap, so that's not your main filter supply. Well, it may be. I don't know what it goes down to. This is a 350-volt cap right here, though. So I don't know what the transformation is on this. So I'm going to have to, like I said, I'm going to find the manual for this thing, find the calibration procedures. In the next part of this video, we're going to calibrate it. Hopefully, we can get it within spec. If it's one of these ICs, then we may have a hard time finding it. If it's a problem with that, I don't see, to tell you the truth, I don't see any adjustments. Oh yeah, okay, I do see them now. Okay, yeah, I was about to say, how would you even calibrate this thing? But yeah, here's a bunch of pots right here on the back. Very easy to get to. I don't know if you can access. Yeah, it looks like you can access them from the back cover too. So that's very good. You got 1, 2, 3, 4, 5, 6 adjustable potentiometers right here. So that's probably how we're going to get this thing in line right there. Like I said, I'll have to find the manual for it. If I can't find the manual for it, and none of you guys out there in YouTube world have this manual, then we're just going to look at the circuit and find out exactly, just physically here on the board, find out exactly what these pots do, maybe with some experimentation on turning them, and see if we can get this thing back into line. I know this is not going to be it's not going to be a precision instrument, and it's not going to be very accurate, but if we can get it kind of close, that would be great. I just love to see the Nixie tubes light up. And again, I apologize for the way the Nixie tubes looked on the video, but I assure you, to me they look crisper than a 7-segment display. Okay, in person here, they look really crisp, really fine lines, not really bright, but just really crisp lines. They weren't washing out like they were on the screen. So, but yep, this is it. This is the Systron is how you say that, I believe. Systron Donner 3-digit Nixie tube multimeter. And in the next part, if I can find the stuff to do it, we'll align this thing, or not align it, but calibrate it to the best of our ability. And if we can't do that, we'll tinker with it a little bit, maybe get it to, within whatever, close. Maybe we can get it close. And then I can start using this thing. I'd love to stick it up here on the bench and have those Nixie tubes glowing. It would be great. We might even do a little comparison between it and this LED fluke benchtop meter right here, which I believe is a 5-digit, maybe a 6-digit fluke meter. But we maybe do a little head-to-head comparison with them. So look out for part 2, and in the meantime, thank you for watching this video.